Hi, in this video we're going to see a brief introduction to message security services. First of all, let me recall our message security scenario. Basically, we have Alice and Bob who want to communicate securely, and we have Trudy who can eavesdrop and modify messages. So what do they mean by communicating securely? Basically, Alice and Bob want to ensure some security services, which are confidentiality, integrity, authentication, and non-repudiation. And we're going to see briefly each one of them. First of them is confidentiality. In confidentiality, Alice wants her message to be readable by Bob and only by Bob, no one else. So could Alice just send the message through the channel so that it's received by Bob? Obviously not, because you have there Trudy, and since Trudy can access the channel, she will retrieve the message. So the usual solution is to use a shared key to encrypt the message. Alice would encrypt her message, send it through the channel, and then Bob would use the same key, which is shared by them both, to decrypt the message and get the original message by Alice. In this case, although Trudy can access the channel, since she doesn't have access to the key, she cannot extract the original message, so confidentiality is not broken here. Integrity is a bit more tricky. Here, Bob wants to know if the message was modified, allegedly by Trudy and in transit. So, interesting thing here is that this setting does not provide integrity. Okay, in this particular case, if Trudy messes with the channel, it obviously would alter the message received by Bob. This message could have more or less sense to Bob after it is decrypted, but if we assume that Alice could send any kind of message to Bob, it hasn't to be a readable text or whatever, Bob wouldn't have any way to be sure that the received message hasn't been altered from the original message that was sent by Alice. We could think whether we could use control bits for integrity here. So the idea would be to, for Alice to add a set of control bits to the encrypted message that she's going to send, and then at the other end, Bob would recompute the control bits and compare them with the ones received so that he can confirm that they match the message. We could think that now, if Trudy messes with the channel, then she would alter the encrypted message received, and Bob could use the control bits to verify that the message has been altered. The problem here is that, of course, Trudy can mess with both the encrypted message received and the control bits, so she could ensure that the control bits match the encrypted message received, and in that sense, Bob couldn't be sure that the message hasn't been altered. A solution here could be, for instance, to use two keys, and keep in mind that this is not an actual solution used in practice. Here, Alice has two different shared keys with both. We have called them K and K prime, and she would encrypt the message twice. She would send two messages, two encrypted messages, one of them encrypted with K and the other one with K prime. Same message encrypted with different keys. It would send it through the channel, and at the other end, Bob would have to use both keys to decrypt the message, the two messages, and then he could compare the two messages decrypted, and they should be the same. Here, if Trudy messes with the channel, of course, she will mess with the encrypted messages, but since Trudy does not have the keys, it is extremely unlikely that when Bob decrypts the messed up messages, these two messages are going to decrypt to the same original message. And in this case, Bob would realize that something wrong has happened. So this would provide integrity. Now we go for authentication. In authentication, Bob wants to be sure that the message is from Alice. The interesting thing here is that the previous construction, the one we were using for integrity, also provides authentication. Since only Alice and Bob have the two keys that are used to encrypt the messages, Bob can be sure that the message comes from Alice, because since it is sure that the message hasn't been altered in transit, and only Alice and Bob have the keys, since Bob hasn't generated the message, it's for sure has been generated by Alice. So we have authentication. Would we have authentication if we were using just one key? We could think so, because again, this key is only known by Alice and Bob, and so since Bob knows that he hasn't generated the message, it has to be that Alice generated it. But the truth is that in this case, Trudy could use just random bytes, and they would be decrypted to some arbitrary message by Bob. So Bob couldn't be sure of the authenticity of the message, while if we were using two keys, it would work. Now, the last of the message security services we're going to cover in this video is non-repudiation. In this case, Bob wants to be able to prove to a third party that the message came from Alice. And here, interestingly, the construction we are using provides authentication, but not provides non-repudiation. So Bob can be sure that Alice sent the message, but he cannot prove it to a third party. Why not? Because since the used keys are shared by Alice and Bob, Bob could have been the one generating the message. So Bob cannot prove that it was Alice and not him. Okay, so this was a brief introduction to the main security services which are used to communicate securely when sending messages, which are confidentiality, integrity, authentication, and non-repudiation. I hope they are clear to you now. Thank you very much.